All right, let's dive into one of the biggest, most important economic stories happening on the planet right now. We're talking about India's massive shift from being the world's back office to becoming a true deep tech superpower. And believe it or not, it all comes down to one tiny little component that I guarantee is within a few feet of you right now. So just think for a second. What's the one thing, the one ingredient that connects the phone in your pocket, the car in your garage, the AI that's changing everything, and even, national security? It sounds complicated, but it's not a trick question. They all share the exact same tiny, powerful heart. You got it, the semiconductor. And this is so much more than just a piece of technology. In the 21st century, it's become the bedrock of economic strength, of national independence. It is, and this is no exaggeration, the tiny brain that runs our entire modern world. And that's exactly what we're breaking down today. This is the story of how India is putting billions on the table in a national mission, not just to get a seat at the table in the global chip race, but to actually win it. Okay, so to really get where India is headed, you have to understand where it's been. And for decades, the country has been living with this fundamental contradiction. We're calling it India's Silicon Paradox. And here's the absolute core of that paradox. For the last 30 years, if you've used pretty much any major piece of tech, a phone, a computer, anything, there's a really good chance that an engineer sitting in Bangalore or Hyderabad designed the chip inside it. But, and this is the big but, for all that incredible brainpower, India itself owned almost none of the final product, none of the wealth, none of the strategic control. It was this massive imbalance, right? On one side of the scale, you have this huge pool of world-class, genius-level talent. And on the other side, basically no ownership. No intellectual property. That is the fundamental problem that this entire new mission is designed to solve, once and for all. So, how do you fix a decades-old paradox like that? Well, you don't just hope for the best. You create a blueprint, a very deliberate, very well-funded national strategy, and it's called the India Semiconductor Mission, or ISM for short. Now, what's really smart is how this strategy has evolved. The first phase, let's call it ISM 1.0, was all about the big prize, attracting those giant multi-billion-dollar factories, what we call fabs. But ISM 2.0, the current phase, goes so much deeper. It realizes it's not enough to just build the factory. You have to build the entire neighborhood around it. That means getting a local supply of all the specialty gases and materials and, most critically, creating your own homegrown intellectual property. And look, this isn't just one simple policy. It's a whole system working together. You've got incentives like the DLI to help local design companies grow. Then you've got this amazing Chips to Startups program, or C2S. That's just building a massive pipeline of new talent. It's what you'd call a full stack attack on the problem, hitting it from every single angle. Now, every great strategy has a secret weapon, right? A disruptive move that changes the game. And for India, that weapon is a massive bet on an open source future for the hardware itself. Okay, to really get why this is such a game changer, we just need to quickly understand one term: instruction set architecture, or ISA. Think of the ISA as the most basic language that a computer chip speaks. It's the absolute foundation that everything else is built on. For decades, that foundational language has been proprietary. It's been owned and controlled by a couple of huge companies, mainly x86 and ARM. If you wanted to build a chip, you had to play by their rules and pay them massive licensing fees. But India is now championing this radical alternative called RISC-V. It is completely open source, no fees, no gatekeepers. It gives Indian designers total freedom to innovate. Honestly, it's for hardware what Linux was for software, a total revolution. And let's be clear, this isn't just some tech nerd decision. This is a profound strategic move. It's all about achieving something experts are calling architectural sovereignty. It's the power to control the fundamental building blocks of your own country's technology without being dependent on anyone else. So that's the grand strategy. That's the secret weapon. But the real question, the one you're probably asking, is any of this actually working? Well, let's take a look at the new builders who are turning this blueprint into actual silicon. The numbers here are just, wow. They speak for themselves. In just a couple of years, the funding for these fabless startups, these are the companies that just design the chips, has exploded. We're talking a tenfold increase. This is that science to capital engine just firing on all cylinders. So how is this happening so fast? It's not an accident.
There's a systematic pipeline in place. It starts with deep research in the universities. That research gets funneled into these government incubation programs, which then helps spin out a startup. And that startup eventually delivers a real commercial product. It's literally a conveyor belt turning PhD research into real, valuable companies.
And we're not talking about generic companies here. This is creating highly specialized world-class players. Take a company like India Semiconductors. They're not just making regular silicon chips. No, they're working with gallium nitride. That's a next-gen material that's absolutely critical for 5G and for electric vehicles. Or look at C2I, a startup that's solving really tough power problems for massive AI data centers. These aren't copycat companies. They are on the front lines solving tomorrow's problems today.
Okay, let's zoom out for a minute and put all this into the big picture, because this isn't just a story about India, it's a global story. And what's happening there has huge implications for geopolitics and the entire world economy. The last few years, with all the global chip shortages, showed us all just how fragile our supply chains really are. I mean, one little hiccup in one country can literally halt 169 different industries around the world. It exposed this risk, what some have called the weaponization of interdependence. And that has made having your own chip capacity a non-negotiable issue of national security for every major country.
But here's the key thing about India's strategy. It's not about building a fortress and going it alone. The goal is actually to become an indispensable and, crucially, a trusted partner in the global supply chain. By working closely with allies like the US, Europe, and Japan, India is positioning itself as that reliable alternative, the China plus one, making the whole system safer and more resilient for everybody. And of course, the economic opportunity here is just massive. We're talking about India's own semiconductor market blowing past $100 billion by 2030. But even that huge number doesn't tell the whole story. These chips are the foundation, the enabler, for India's much larger goal of building a $30 trillion economy. So the big takeaway here is really simple. This is not a dream or a plan on paper anymore. It is happening right now. And as this final quote so perfectly puts it, the roadmap for a developed India, it's literally being etched in silicon. And for the world's innovators and investors, the message is clear. The time to tape out, that's the final step when you send a chip design to be manufactured, is now.